Alright, so for this assignment, I want to review question number 4 on the third assignment, which is thermal energy calculations for this week. Now, hopefully, before even watching this video, you have gone through and at least looked through the thermal energy notes that are in your packet, or you have watched the YouTube video that I have included in the email link as well. You can watch that video. It goes through the notes a little bit more in depth than what the packet does, but those are kind of your two options. So hopefully you've at least watched the video or gone through the notes before trying to attempt these problems. But just as a little bit of review, don't forget that we can actually figure out the change in thermal energy, or basically how much heat is added or lost in a problem, by using the formula Q, which is the heat basically, is going to be equal to the mass of M multiplied by the specific heat of the substance, which is C, multiplied by the change in temperature, which is represented by TF minus TI, or the final temperature minus the initial temperature. So that is the formula we are going to use for this problem, and feel free to have your assignment out in front of you and be following along as we go through this. But basically, we are going to go through this problem, and it is asking us how much energy must be absorbed by water with a mass of 0.5 kilograms in order to raise the temperature from 30 degrees Celsius to 65 degrees Celsius. And we also know that water has a specific heat of 4,190 joules per kilogram Celsius. Now, don't forget the solution for this problem is also in your packet as well, but it's not a bad idea to watch through the video and make sure that you are good with the process, because you can use this exact same process in the other questions that are on your assignment, because there are other questions on your assignment that are just like this one, where you are going to be calculating the energy, or the thermal energy, which is basically just Q in this problem. So that's all we're looking for in this problem. So the very next thing you should do is you probably should go over here and you should start to define your variables. So we know that in this problem that it is going to have, or the water is going to have, a mass of 0.5 kilograms. So we know that the water is going to have a mass of 0.5 kilograms, and we know that the specific heat of water, because it's given to us right here, we know the specific heat of water is going to be about 4,190 joules per kilogram for every degree Celsius. And we also know that the final temperature, because we know we're raising the temperature from 30 to 65, we know the final is going to be 65 degrees Celsius, and we know that the initial is going to be 30 degrees Celsius. So that is right there, all the variables that we do know, and then we are solving for Q down here. So we will write a little bit of a question mark. So that is the very first thing you should do every single time when solving these problems, especially because if you think about it, there are 5 variables in this problem. There is Q, which is heat, there's mass, there's specific heat, and there's 2 different temperature values. So it is very good to keep you from getting distracted or maybe messed up a little bit. It helps if you can make sure that you define all of your variables before moving on. Especially, you don't want to make sure that you mess up your final temperature and your initial temperature, because that really would mess up your problem, and it most likely would get you a negative answer when it should be a positive answer. So make sure that you are defining your variables. That's the very first thing. And the next thing we can do is we can just start to plug into our equation. The nice part is this is a pretty simple problem, and the fact that we really don't have to rearrange anything. We know we are looking for Q, so the fact that we're looking for Q, the nice part is we already have Q equals. So we basically can just take all of our values here and start to plug them into this formula. So we can rewrite it as essentially Q equals, we know that the mass I just said was 0.5, so we'll do 0.5, and that's going to be multiplied by the specific heat of water, which is 4,190, and then that is going to be multiplied by the change in temperature, which is going to be 65 minus 30, so 65 degrees Celsius minus 30. Remember, our final temperature minus our initial temperature. Now, hopefully you remember your order of operations, because to solve this, I would highly recommend that you take care of these parentheses first, that you take care of the subtraction that is in this parentheses. Remember, please excuse my dear Aunt Sally, or purple elephants may destroy Alexander schools. I've heard that one as well. Make sure that you are following that order of operations when solving these. So the very next thing I would do is I would just simplify a little bit, and I would rewrite it. We know that Q is equal to 0.5 times the specific heat of water, and then now 65 minus 30, that should be 35 degrees Celsius. Basically there is what's going to be left for your temperature. And then the last thing you got to do is basically just plug this into a calculator. Any calculator will do, because all we're doing here is multiplying all of these values. So it should be 0.5 times 4,190 multiplied by 35 degrees Celsius, and your final answer should be that Q, or heat, is going to be equal to about 73,325. And then ask yourself what the units should be. If we just calculated energy, what's the energy units? And it should be joules. So that right there should be your final answer for this problem. 73,325 joules. And all you had to do is make sure that you defined all of your variables, because pretty much everything you need is given to you in this problem. You just have to make sure that you can go through and pick out what variable is which, and make sure that you have the correct units on your final answer when you plug everything in. And not a bad idea to do this subtraction here first. Do 65 minus 30. That is something I recommend you do once you plug it in to the equation. I recommend that you do this first every single time, and just to make sure that you don't have any calculator errors, it's a good idea to do this as well. So hopefully this was a little bit helpful. There are other problems that are exactly like this on your assignment for this week. Again, if you have any questions, feel free to email me. You know my email. It's on the very first page of that packet, and I hope you have a great week.